All right, we've got an initial velocity vector of 8i and 6j, which means this is 6j, this is 8i. So express its velocity at time t. So remember, initially, x equals 0 and y equals 0. So the x component of the displacement at the initial is 0, and initially the y component of the displacement is 0. And we know that the x component of the velocity is 8 and the y component of the velocity equals 6. We also know that because it's projectile motion, x dot dot is always 0, y dot dot is always -10. Hate that. So we're going to need to integrate the acceleration to get the velocity. So x dot is the integral of x dot dot dt with respect to time. So it's the integral of 0 dt, which gives me 0t plus a constant, c1, which just gives me the constant. The y component of the acceleration, of the velocity, is the integral of the y component of the acceleration with respect to time. So we've got the integral of -10 dt, which means it's -10t plus c2. And to actually find c1 and c2, we're going to have to equate what we know. We know this, and we know at t equals 0. So x dot equals c1 equals 8. So c1 equals 8. So we know x dot equals 8. Like with, not just a t0. Okay, at t equals 0, we know y dot equals -10 times 0 plus c2 equals 6. So we know c2 equals 6, so we know the y component of the velocity is -10t plus 6. So we can express v as xi, so 8i plus yj, so it's -10t plus 6j. So if we expressed it how they wanted. Okay, question B. Express the displacement at time t in that form. Okay, so we're going to do something really similar for the displacement. So integrating, so we know the displacement is the integral of the velocity with respect to t, which means we're integrating 8 dt. So we've got 8t plus, and I'm going to just call it c3. We know the y component of the displacement is the integral of the y component of the velocity with respect to time. So we've got the integral of -10t plus 6 dt. So we've got -10t squared onto plus 6t plus c4. So it's -5t squared plus 6t plus c4. We know at time t equals 0, We know x is 8. X is 0. So we've got 8t plus c3 equals 0. Well, it's 8 times 0, sorry. I'm getting this from and this will be similar. So we get C3 equals 0. And we know the overall equation for the displacement is 8t. We know y is -5 times 0 squared plus 6 times 0 plus c4. It's going to come out at 0. So c4 equals 0. So the actual equation for y is -5t squared plus 6t. So we can express the overall displacement, the overall equation for the displacement, as similarly like we did above, 8t in the I direction plus -5t squared plus 6t in the j direction. And for question C, I'm going to have to copy this. We want the initial speed of the particle. So this is without direction. So if it was going 8I 6J, we just want the resultant, which I'm just going to call V. So V squared is 8 squared plus 6 squared. So V equals 10. Let me double check if this is Pythagorean triad. 8 squared plus 6 squared, yep. So we've got an initial speed of 10 meters per second. The position vector of the particle after 2 seconds, so this is r, when c equals 2, r equals 8 times 2i plus -5 times 2 squared plus 6 times 2j. So the position vector is 16i. -5 times 2 squared plus 6 times 2, take 8j, and we want number 3, position vector of the particle when it reaches its greatest height. So I'm just going to draw a little diagram. It's going up and down. Its greatest height is here. And that point is when the y component of the velocity, we're stopping going up and we're starting going down, and it's exactly the point, it's at 0. So let's find the time for that. So y dot was, what did we come up with? -10t plus 6. And that's 0. So we're going to solve for t. So we've got -10t equals -6. So t equals 0.6 seconds. So it's going to reach its maximum height at 0.6 seconds. Then we want the position particle, the position vector then. So r, technically I should have things under these r's. That's going to annoy me if I don't do it consistently. Okay. So r is going to be 8 times 0.6 plus -5 times 0.6 squared plus 6 times 0.6 j. So I've got 4.8i. The position vector is 4.8i plus 1.8j. That's it.